Mike wasn't aware that we're doing this today, and I thought we could ask him to do it. But I think this is a pretty amazing project. So.
Yeah, thanks for the opportunity, Scott.
So we basically have more projects than we have people.
Yes.
Today, because lots of people cancelled, we couldn't make it. It's like really short notice. So.
No, that's cool. That is how it should be. It's short notice to be here.
Yeah.
Right, my name is Mike Barker. I'm an electrical engineer, and I've got a few ideas that might be of interest to you. There's an area that's growing called wearable electronics. And out of that flows a number of things that we can do to interest kids in electronics. Engineers are the only people who add value in this world. All the other professions. Let me tell you why. All the other professions shuffle money between A and B. Engineers create money out of nothing. And that's what we want in this country. We need far more engineers, technicians, technical people creating things out of nothing. The ideas about headphones, all these other ideas, that's what we're going to be doing. So how do we get our youngsters involved and interested in electronics? Wearable electronics gives us the one single thing that every youngster wants, and that is a hoodie with everything built in. So the first project I'd like to see, and we have the material, is a hoodie with a Bluetooth-enabled speakers, so that via their cell phone they can play music into the hoodie and share that music with their companions. And the way to do it is, I found on RS Electronics a Bluetooth speaker unit. We're going to repurpose that, rip it to bits, I believe, and stick it into a hoodie. Okay. I have something called the LilyPad system that you'll find on something SparkFun. Okay, we've got a whole large amount of it here, including LEDs. This is one of the development boards. LEDs, more LEDs. There's a buzzer, there's a small speaker, there's an accelerometer, and I'm not sure, a switch and a couple of other goodies there. So we want to build this into a hoodie, right? So that when the person is moving, dancing to the music from the cell phone playing through the built-in speakers, the accelerometer will pick up the movement and start flashing various LEDs. Okay. Yeah, okay, so that's the basics, and I think that will gain the attention of a lot of perhaps non-technical people, show them that you can do a lot with programmable controllers, a couple of LEDs, and of course good music and a bit of physical exercise. Okay, and when you start talking about wearable electronics, one of the first things that you'll notice is there's a big drive now to use these wearable electronics to monitor your vital statistics in terms of heart rate, pulse, and many other things. Now what I've got here is the unit that was used, well, perhaps in the news, most popular about a year ago. A whole lot of miners got stuck down in Chile. They appealed to NASA to help out to keep these guys alive before they could drill down and get them up. So what NASA said is you need to monitor their vitals, and they use something called this Zephyr bioharness. So here's one of the units, you wear it, it monitors your skin temperature, heart rate, breathing rate, and there's a couple other things. It's got connectivity, ECG, right? Bluetooth, you can pick up ECG. So this works with Android phones. There's a number of Android apps. I'm running it on a Galaxy Tab and on an Android phone. So you can link this and monitor it. Okay. What comes out of all these wearable electronics being used, this is just a simple heart rate monitor. What comes out of all these wearable electronic systems is an idea that I'd like to explore, and I'd like to appeal to those of you who would like to take part. We've got the equipment, we've got the funding. What we do need to do is build a system to help blind rowers. Right? Rowing is a sport that's very popular, and it lends itself towards disabled people of various sorts. It gives these people an opportunity to go out, the freedom to take part in sport and to take part in social activities. One of the biggest issues when you have a boat of 4 partially sighted or perhaps even blind people rowing is synchronization. Now what we're hoping to do is to take a strap and take these lily pad buzzers and build the buzzers in and then monitor the slide. Rowers sit on a slide that moves up and down as they row. We've got to synchronize them moving up and down. So as the stroke or the lead rows, they slide moving up and down. We want to pick up that movement and transmit it to these bands that the other rowers, the other 3 rowers will be wearing, and using the vibrating sensors and maybe even sound to give them some indication of what the stroke is doing so that they can synchronize themselves with that person. And if we can get that right, I believe it will assist with the training. There is an opportunity, of course, to help one of our squads, which I believe will probably be going to the Olympics in 2012, June, July, so there's some idea of the timetable. But if that doesn't occur, there are certainly longer plans to make use of these systems. The next system that comes up is the ability to help a blind rower in a scull. That's a single person rowing by themselves. In the past, you would have somebody else, a sighted person in the boat, directing them and guiding them. But with GPS technology, there's no reason why that blind person can't be guided. And in other words, row by himself and have some understanding of where he is on the course and which direction to go. Overseas, there are blind people that take walks through parks along a fairly flat track, and they have a GPS that guides them using an audio, a set of spoken commands, much like you use in your car. And they get to go out and enjoy themselves. South Africa has a proud tradition of disabled people competing in able-bodied sports. Oscar Pistorius, we're all holding thumbs for him, and certainly we'd like to see our blind rowers maybe someday if they're strong enough competing in able-bodied sports. So the idea then is to build a GPS into the boat and to communicate wirelessly with this belt and via a system of buzzers to guide the rower and keep him on course. Basically vibration units on this side and on this side. And if he goes too far in the wrong direction, it will vibrate you and almost push him back on course. And that I believe can be done as well without too much effort. All the components we need, we already have, the GPSs, the controllers, the vibrators. We do need some sort of wireless technology, and speaking to Skulk, he recommended, it would have been the XB, I think, which is also available. So we don't want to build from scratch, we want to repurpose components, we want to take things that are already there and integrate them and produce these systems. So I'll leave you with those 2 particular projects. Thank you.
Excellent, thank you.
There's a very nice video clip that you sent me. I'll just put it on the mailing list. It sort of shows one of the training efforts for these blind guys, and it's like truly like moving. If you see what the guys are, they sort of come in there. They've got no coordination, no, and they go away and they run these teams. And it's like,
nice.
It's really great. Once you've seen it, you want to join this project. I promise you.
It's good to say, do you know any blind people that can test your stuff?
Yes, look, we'll start testing on able-body rowers in the beginning. We don't experiment with just anybody. So there are plenty of able-bodied kids rowers that we can bring in and are willing to test this. At the moment there's an Italian coach out helping they call it adaptive rowing. They adapt the boats for the particular people. Some of them don't have legs, arms, spinal injuries, and then of course the blind people themselves. So there's certainly a lot of people. The school that Skulk was talking about is called the Arthur Blexel School in Maritzburg, and it's for partially sighted and blind people. And they've got, via the South African Lotto, they've got a couple of boats, and they're using those at the moment. There's also a team right here in Johannesburg, and they're preparing for the Olympics, I understand. So we've got to be careful there. We can't go and experiment with them. We need to experiment with other people, and only when the system is well commissioned and working well, then we can take it and offer it to the Olympic teams.
You know, well, the reason I'm asking is when I still worked for my previous company, we interviewed a guy which was blind, and I kid you not, he was the best programmer I've ever interviewed, and he was completely blind, and it was just amazing. And me and a fellow colleague of mine, we interviewed him, and we're like, sure, we would love to work with you any day, come. And at the end of the day, he never started there because of my boss that said, yeah, it's going to be a problem with the dog and it's going to poo in the office. And it was just like kind of sad to not give him the job at the end of the day. But yeah, he would definitely be interested in
well, there you go. If you've got his details, we have got funding to assist him. Okay, and we've got the equipment, it's sitting waiting, we just have to find somebody with an interest.
Yeah, and even if he doesn't do physical programming on it, but he's more than capable to, I'm sure his input will be more than, will be amazingly valuable for him.
In the Python community, there's also the guy, the blind biker, and who's in the Python user group. Nobody. There's the Python user group, there's this guy called Blind Biker. He's sort of
yes, I've heard of him.
Recently blinded guy, but he writes awesome. He writes these game engines and Jacob.
He doesn't bike anymore.
I don't know.
The other guy's great, but yeah, I can definitely get to the details on that.
But I mean, we could to possibly make contact with him.
Because one of the criteria or criticism my boss had was like, yeah, but how are we going to explain UML diagrams to him and stuff, which was
no one needs that.
Kind of nasty, but I mean, then he wrote a program to illustrate to us how you can do it by literally saying things so that you can draw it. So it will say circle A, connect circle B, connect circle triangle, blah blah, so that he can draw stuff for us, but also for us to, as long as in a digital format, you could read it to him in a way that he can understand it. And I mean, yeah, but still, he can definitely contribute. So
look, I mean, there's another aspect to this. Clearly, the likes of Carte Blanche, the newspapers, they love stories where these things happen.
And also publicity for House4Hack.
Yeah, so there's potentially publicity there.
Especially before the Olympics.
So my mind's already got into problem-solving mode. So how noisy is it on the boat? Because
it can be very noisy when you've got a quad, 4 people rowing. The cops are shouting commands to them all the time. There's a lot of noise. There's
so you can't have a variable tone as they slide up and down. I think
the metronome, the metronome we believe the sound will interfere, and often enough the other boats close by.
So that's why you've opted to more for the physical feedback, like a vibration.
Yes, because we understand helicopter pilots also face the same problem, and the American chopper pilots use a similar system to provide extra input.
Unless the coolest headphones in the world was waterproof.
and did noise cancellation.
Well, that's nothing.
Well, on the noise cancellation, I think the guy I spoke to, well, my previous boss actually, I spoke to yesterday about it and said some of the police has got certain PTT radios that's got noise reduction in the voice part, so that people can be shooting around you and shouting and whatever, but your voice goes through to the other side perfectly clear. You can have that built into there.
That's
along with the
screaming like a girl at that point.
No, that can definitely be in there.
So how would you kickstart your project? Would we get a rowing machine in here and start working on it? I mean, how do you translate all the...
What we do is we've got a couple of old boats, so what we'll do is I'll actually go and cut one up so that we've got the slide on the rails. The rails are about 85 centimeters long on a slide, and we can slide it up and down, read switch, pick it up, and then practice with that. Then the next step would be to go through to the ergos. The ergos are these rowing machines, okay? And then we'll put 4 people on the ergo. We'll take one of them and we'll blindfold them. These are, we'll grab a couple of matric students perhaps, or the youngsters. We'll offer them pizza and all sorts of things to draw them into our lair. And then the one will be the stroke, and we'll pick up the movement as they row. And then we'll have the other 3 side by side, put a video camera on it. and they'll wear the straps. The straps have to be wireless because if the boat turns over, we can't have leashes or bits of cable on. It must be a wireless communication with the strap. So the three of them will wear these straps, and we'll see if they can row and sink. Now, the difficult part is we don't really know what to do. We think that when they get to the end and you want them to start moving forward, then you start vibrating on their back, so that sort of pushes them forward. And when they get to front stops and you want them to start going back, then you vibrate. But clearly you also have to get those signals to be strong or weak according to whether they're in sync already or whether they're out of sync.
Yeah, you need continuous feedback.
Yes, continuous
so
feedback.
do you want to, because there's sort of two kinds of approaches here. You want to give them a signal of how close or how far they are in sync. That's one way. The other one is to give them a sense of their proximity to the other rower. So if they could feel a compression or I mean, you could do it with an airbag that blows up and goes. You know,
I was
they
going to ask if they
just push harder and push, and they know whether they're closer or further away. So there's two different. Because I don't know how a blind person might perceive different senses, but I'm sure you can
Don't
learn.
they have life jackets
They are
on?
very good at
No, they don't
cheating.
wear life jackets, but there is a safety boat there. I'll give you some idea. One of the ladies that rode in what will become the Olympic team, they've just come back from the World Champs in Germany, and it was only after about rowing for a year that she finally suddenly clicked on her which way the boat was physically moving.
Yeah.
Okay, because they always say blind rowers can row because normally you sit with your back, you're not watching, you actually sit with your back in towards the bow of the boat, the direction you're going. And so for the very first time she actually said to somebody, she suddenly clicked which way the boat was going. She wasn't even aware which way the boat was going. So it's hard to tell what they, but I mean this is the crux of the matter. It's an experiment. And we will start with able-bodied people and see how they feel and whether it works. And you're right, the vibration buzzers might not be sufficient. You may well have to have something that exerts some sort of hydraulic pressure.
I'm thinking
on them.
tightening and loosening of a chest belt,
Okay.
almost like breathing. Because if you think about it, you breathe in and you breathe out, it's the same as you slide to the front and you slide to the back. So it's easy to synchronize it if it's like tightening and then loosening, tightening and loosening, and then you know exactly where you are in this, and you can use a simple servo motor for that or something like that.
Just by the way, the reason why the voice, or even if they used headphones, every one of the other three rowers need different sets of commands. You see what I'm saying? So you can't say rower number one faster, rower number two slower. You will never be able to give all that voice command.
Plus, it needs to be waterproof and all sorts of things.
Waterproof, no, certainly.
It's important for the environment and everything else, not just waterproof.
Yeah.
Yes.
Big oars, someone fall over, break that stuff. It's
Well,
expensive.
gotta be robust,
waterproof and strong in any case.
They've got those new nanoparticle stuff they spray on cell phones now that supposedly makes it waterproof. So.
I'm thinking if one can combine all of that stuff with the headphones, with the Bluetooth, and the chopper. The chopper can fly ahead with a little radar thing to check for obstacles and
Like
the
waterfalls, for
feedback.
example.
Send the feedback. There's a big rock. GPS won't be able to tell you that.
Yeah.
So,
Like rapids, how did they get through rapids with GPS?
Only thing is it's a 6-minute race for this job.
I'm sure it's a clear.
well, it can come back quickly, recharge, like a docking station. It just goes and sits, gets the new battery, goes ahead again, reports back. Yeah.
But like the details you guys can work out.
Okay, I would just like to quickly comment on the sensor part here, and we must remember that humans are actually fairly intelligent and can adapt quickly to sensoric input.
Some of them,
Yeah,
You don't-
I was just
some of
gonna
them,
say,
yeah.
it's a generalization.
So you don't necessarily have to create a sensor that goes. As long as you've got a synchronization part of like, okay, I'm still out of sync. I can feel it's at the front, it's at the back. A human will quickly adapt to,
That input channel.
and you've got one single master node going. This is how we're supposed to run. The rest just needs to follow that. So
I just thought of a name for the project, the Pavlovian, because it's a response to sense,
Exactly.
to input, and also because we're going to feed the students
Pizza.
make them participate in the experiment.
that's actually cool.
You think that'll be enough? If that was pushed onto your body?
Also, if you exert it, you have to get it in somewhere specific that you feel
Yeah,
it.
it's easy feel.
Yeah,
The thing
that's
is-
the belt.
So the thing is, if you're sitting in that thing and you're going crazy, you
And
get
it's
a
almost
back and
not
try and
like
think
a
about
one
that.
off. You can go faster and slower on that whole thing, right?
Yes,
So-
yes, yes.
Okay, but if you can change
It's
the
vibrating.
rate of vibration, you can actually give them a relative position.
Yeah, yeah.
Okay.
You can pass it around there, you can feel it vibrating.